balancing length. This is a very important same we are approaching towards a point where current. This is our balancing length. 48.1 hour an experiment of class 12, which is known as basically meter bridge. And with the help of this experiment, we can find the resistance of this unknown wire. We have made a connection of experiment meter bridge. This is the unknown wire made up of nichrome, and we can find the resistance of this wire by using meter bridge experiment, and this is the setup which we have to connect. In this setup, we have a battery eliminator for power source, and this battery eliminator is basically used to provide power to this overall setup. And you see that this is the positive terminal of the battery, and it is coming to the meter bridge to this terminal. It means current is flowing like this, and through this wire it is flowing to this terminal, and it is then connecting to the negative terminal. It means the external circuit on the meter bridge is connected. Now in this small gap, we just connect a known resistance which is being given by this resistance box, and in this gap we just connect a unknown wire of some resistance. This condition of Wilson bridge says that if this resistance is P and this resistance is Q, and in this wire we have some resistance on some section of length. So if this is P, this is Q, this is R, and this is S. So P by Q is equals to R by S. This is the balance condition of Wilson bridge. And at that point, when this balance condition comes, the current in the galvanometer we have connected here, this current detection becomes 0. And this is the equipment which is known as jockey, by which we can detect the current at any point of time, whether it is flowing or not. First of all, we will provide power to this from this battery eliminator to this meter bridge, and we will check our connection is correct or not. For that, we will simply put this jockey at the left end. We have current here. If I just shift the jockey towards right direction, we are still having some current, but the magnitude of current has decreased. As you see, a point comes where the current comes 0. You see that at this point, current in the galvanometer becomes 0. Now we will provide a certain amount of known resistance through the resistance box, and we will start from the smallest resistance. So let's take 1 ohm resistance from this unknown resistance box. Reflection is in right direction. Still we have current, still current, still current, still we have current. As you see that the galvanometer is less sensitive at this point, means we have just approaches the 0 current at this point. You can see in the galvanometer we have 0 current here. You can just see here in the galvanometer. In this galvanometer we have 0 current. Backward we have current in leftward, and if we move this point we have current as 0. So this is the balancing length. This point is balancing length. We can just measure it from here. That is basically 0 to, it's basically 66.5 centimeter is the balancing length for 1 ohm resistance.